So we're actually going to revisit here at the end of our unit, Riemann sums, but we're going to use more than just rectangles because rectangles are great. They're easy to calculate their areas. They're easy to add up. However, they don't give very good estimates unless we go to a lot of rectangles. So if I want to use the same number of shapes but get better estimates, I have to use something besides rectangles. And in this series of videos, we're going to look at Trapezoid Rule for both AB and BC, and then Simpson's Rule for BC only. So with Trapezoid Rule, I don't feel like I need a ton of explanation here. It's that we're using trapezoids. The difference is our trapezoids are being laid on their sides. So the bases are not going to be the top and bottom. Our bases are going to be like this. Remember, in a trapezoid, the bases are the parallel sides. So this would be base 1, and this would be base 2. And the height is the distance between the bases. So our height is not vertical. The bases are vertical, the height is horizontal. And then the area of a trapezoid is 1/2 the height of the trapezoid times the sum of the bases. Or you can also think of it as it's the height of the trapezoid times the average of the bases. So I'm going to use the same example we did RAM with way back at the start of this unit. The integral, we're going to estimate the integral from 1 to 3 of x squared. So I've got 1, and if I'm going to use 4 partitions, it's going to be at every half here. But instead of worrying about left, right, or midpoint, I'm literally just going to use each of those x values and say, well, let's connect them. And now I have 4 trapezoids. The height is the distance between the x's. The bases are going up until I hit the function. So this has a base of 1. This is a base of 1.25. I'm sorry, 2.25. So base of 4. This is 6.25, and this is 9. So then I just need the area of each of those. So if I start from the left, I have 1/2. The height is 0.5. The bases are 1 and 2.25. The next trapezoid, I have 1/2. The base is the height is 0.5. The bases are 2.25 and 4. My third trapezoid, I have the 1/2, a height of 0.5. The bases are 4 and 6.25. Then for my fourth trapezoid, I have 1/2, height of 0.5. The bases are 6.25 and 9. And then if I add all of those areas up, I get 8.75. And there is my estimate. I can also be asked to do the trapezoid rule from a table of values. So here I have a table of temperatures. So an observer has measured the outside temperature every hour from noon until midnight and recorded them in the table. I want to estimate the average temperature for the 12-hour period using trapezoids. Now, some common mistakes that would happen on a problem like this. Most people see, oh, I need the average. Let's add up all those temperatures and divide by how many I have. That would be a mistake on the AP exam because if you're not doing calculus, you're probably not doing it right. And please note it said average temperature. Temperature is a continuous data. It's not, we don't go from 63 to 65 without hitting every value in between 63 and 65. So there's an infinite number of temperatures that I have to take into account in this 12-hour period. So I have to treat this as the average value. So I need the average value of temperature, which is going to be the 1 over b minus a times the integral from a to b of my temperature data. Well, because I don't have an equation for temperature, I have to use the table, so I can only estimate this. And this is where it says estimate using trapezoids tells me there should be an integral involved in this. So I have the 1 over b minus a, which will be 12 minus 0, times the integral from 0 to 12 of my temperature. Oops, sorry about that. And this is where the estimating comes in. So I have 1/12. Then for the trapezoid rule, again, you can sketch this on data if you need, but here are where my heights will be, and here will be my bases. So I have 1/2. The first trapezoid has a height of 1. My bases are 63 and 65. For my second trapezoid, I have 1/2. Going from 1 to 2, I have a height of 1. The bases are 65 and 66. I then, for my third trapezoid, have from 2 to 3 is a height of 1. My bases are 66 and 68. And I can keep doing this all the way up till I get to my last trapezoid with height of 1, bases of 58 and 55. And then I have to make sure I'm including that 1/12 after I do all of the green part. And when I do, I get an average temperature of 64.417, which is a reasonable answer based upon the data that we can see.